when the CDC needed a vaccine management system, they didn't need it in a year and a half. 18 months was not the time frame we had. Okay, can you get something done in a year or two? That was not, no, we had to do it very, very quickly. We were in a crisis. So in a sense, it made things very simple. Our choices were very simple. We couldn't use the tools we had used to build our previous applications. We had to do something that would allow us to build applications much faster. So we went to the very latest version of our database, the Oracle Autonomous Database. And the interesting thing there are many interesting things about the Autonomous Database. One is that it tunes itself. You don't tune it. It provisions itself. There are no DBAs. If it breaks, you never know because it fixes itself. It's not that it never breaks. It's just fault tolerant. It breaks, it recovers so fast, you never know it was broken. Almost all the security problems found in databases are caused by people making mistakes, not configuring the system properly. Some kind of error has opened a vulnerability for your database. Well, if there's no human labor, not only you save a lot of money, but even more important, you eliminate human error because you don't drive the car. The car is robotic. One of the great things about self-driving cars is not that they, when you hail a cab from Uber, it's not that it will cost less without a driver. It's that it won't crash. It won't crash. It's just much safer when it's robotic. They're much more reliable. No human driver, virtually no crashes. No human labor in a database. No one's making mistakes, and no one's being malicious. So we adopted the Oracle Autonomous Database. We also adopted a new programming language called Apex. And Apex is a low-code development environment where if you write an Apex, Oracle puts all of its applications through a security audit. I mean, Edward Screven and his team will looks at code. I mean, it's very difficult when we come up with a new version of one of our applications. It doesn't get published. It doesn't get released in our cloud until it passes a security audit, unless it's written in Apex, and then there is no security audit. Or you just you record it as like an Apex, all Apex checkmark done, because the security is built into the environment. You can't do anything in Apex to create a certain security vulnerability. The other thing, it's true. Other thing about Apex, which is really interesting, it's a stateless application. I'm not going to go there. You can't build a stateful application in Apex. I'm not going to go into deal with exactly what that means, but one of the benefits of not having state in the application, if your application falls on its face and breaks, that let's say you lose power in the computer, the data, a forklift, rips out a power line in the data center, something, the whole thing goes down. It fails over to another data center automatically in less than a second. Now, what did I have to do in my Apex application to make that possible? Nothing. Nothing. It's more secure. It's more resilient. And you can develop in a tiny fraction of the time. Again, easy for me to say, but when we developed the vSafe system for the CDC to manage and to gather information about people who were vaccinated for COVID-19, it took 68 days to build. 68 days. When we worked with the University of Oxford and rewrote the GPAS system, the Global Pathogen Analysis System, which I'll describe in more detail later on, it took 3 months. Everything was in a matter of days or weeks or a couple of months. We've proven we can get huge productivity gains by moving to modern development technology. We learned that when, in a way, we had no choice. We had to try these tools. We made these tools better during the COVID-19 pandemic, but we proved to ourselves we could be much more productive. And once we realized how productive we could be with the new tools, we got much more ambitious in the kind of healthcare applications we wanted to build.